Okay, this video is about vectors, which I think of it as a topic about journeys. It's always got two parts, or often has two parts, I should say. The first part is just basically you have to name various journeys. The journeys are indicated with a starting point and a finishing point, and the direction of the journey is indicated by the little arrow. So that's the journey from O to A, and our job is to name the journeys. Now they'll always give you little names already. So OA is named A, which often will be done in bold or with an underline. So that little stretch there is A. And they've also told you that that stretch there is 2A and that stretch there is 3A. That's important because, like in other areas of maths, we try to use as few letters as possible when we're naming these things. We do not use D's and E's and C's if we can use A's and B's. And we're going to try and do this entire question without needing any names other than based on A's and B's. Now, sometimes you do have to use a different letter, but if two vectors are pointing in the same direction, then you can borrow the letters of each of them to form the letters of the others. So that's why that was A, that was 2A, and that was 3A. Doesn't matter where the journey is, if it's the same length in the same direction, you get to use the same letter. So that's A, and that's A. We're told that this is a midpoint. Yeah, it says there that... oh no, it doesn't directly say that. But it says that that's B and that's 2B. So for that to be the case, that would have to be the midpoint. So that's B, etc. Now, we're also told that that's a midpoint there and that's a midpoint there. So let's do some names. Now, the way you do these names is don't necessarily start with what you've been given. Instead, just get into the groove. So first I'm going to name the journey from there to there. I'm going to go indirect because if I go indirect I can use names that I already have. That journey there is 2B. So I'm going to name OF here. OF is initially 2B and then EF. And EF, I'm going to borrow that name from down there. It's the same length in the same direction. So there we go. We've got the B part and then the A part. Simple as that. I'm now going to name E to D. How could I get from E to D? Well, I'm going to go backwards down this route. So that's negative 2B. If you go backwards down something, just stick a negative in front. And then forwards along that. So that's that one done. And now that I'm in the groove, I'm going to actually give what they've asked for. So, how could I name the journey C to E? Okay, well I'm going to go backwards along there, that's negative 2A. And then forwards up there, that's 2B. And in this topic, it's a good idea to factorize stuff even if you're not asked to, because it helps you have clever thoughts later. So that's part A there. CE is 2 outside a bracket, B minus A. Now here are some more names. They want OG. Now, when you're doing these, try and use names that you've already got. So, how could I get from O to G? Well, we were told that this is a parallelogram, so that's 2B as well, because that was 2B, that's B. So let's go 3A and then plus B. What about OH? Oh, OH is half that, okay? So I'm going to take the name from OG and just stick a half in front to express the fact that it's half as long. This is an illustration of how don't just look at what you're initially given, look at all the names you built up along the way. We've got names for OF, ED, CE, and OA. I just named the OGs. What about the 8? Well, for O, so backwards to O, up halfway along there. But I've already got the name for OH, I'm going to borrow it there. Now I'm going to tidy this. That is half a b, and then 1.5 of an a, take away 2 lots of a, so that's negative half a. And as I said before, I try and factorise these things even if I'm not asked to. Okay, now next thing is to show that CE is equal to 4. So show that, oh sorry, you probably can't see these arrows here. Show that the journey CE is 4 times longer and in the same direction as CH. And if it wasn't in the same direction, you wouldn't just be able to stick a number in front of it. So CE. Oh, we've already got. We're done. Because here's my 2 vectors. There's a half in front of b minus a over here, and there's a 2 in front of b minus a in the name for CE. So you just simply go CE equals 2b minus a. For CH equals 4 times, and then borrow the name. And they're equal to each other. Now, what fact do you deduce about CE and H? Well, here's the thing. This, we've got a name for CH. It's half b minus a. In other words, it's built on b minus a. We've also got a name for CE. It's 2b minus a, so it's built on the same basic name of b minus a. We wouldn't have been able to do that if that and that were not in the same. So therefore, C, H and E must be on the same straight line, but we use the technical term, which is collinear, and then you always use this standard wording for your little conclusions that you have to draw from your naming. You say because CE is a lengthening of CH, and then you say half b minus a, or you go 2b minus a versus half b minus a. So basically you just lay in front of them that the 2 vectors you're talking about are built on the same basic name of b minus a. That's why factorization is a really useful tool. It makes it much more likely that you'll spot things of that nature.